in order to calculate z-scores, we're going to use this formula right here. X stands for our piece of data. The mu letter right there, the Greek letter mu, stands for our mean, and then the sigma letter down here stands for our standard deviation. So if we have those three values, or any three of those values, we can find any missing variables we want. So in this first example, we're going to find a z-score, find z. So to do this, we'll use that formula and plug in what I've got. Our x, our data point, is going to be 18. Our mean, our average, is going to be 22 for mu, and then our standard deviation is 3.1 for sigma. So that's what I need to simplify there. That's not too bad to do. I'd end up doing -4 divided by 3.1, and your z-score comes out to be approximately -1.29. We're going to always use 2 decimal places. This will be an important fact for what's coming up, what we're doing next with z-scores. So make sure you always round to 2 decimal places. So finding your missing values isn't really that difficult as long as you know your formula. But what I also want to do is provide a visual interpretation of what all these different numbers mean. And so down here I have a sketch or a graph of a normally distributed data. So let's go ahead and add some numbers to this to see what's going on. So the first thing I always add is I add the mean in there, where the middle of your data is for this normal distribution. So my mean was 22. So I'll label that. If you want to label these with letters, fine. That's the Greek letter mu right there. I can see that my standard deviation was 3.1, and since my z-score was negative, I must be below the mean. And so what I'm going to do is I'll go ahead and put a little mark down here, and if I subtract 1 standard deviation, 22 minus the 3.1 value gets me 18.9 as this point right here. And I could keep subtracting 3.1 if I wanted to get other standard deviations. I could also go above and add the standard deviation. Whichever way you want to go, depending on the data you have, is fine. So that's 18.9. Well, the next thing I'll add in there is where my data point would be. My data point was at 18, so we're even a little further. So I'm going to just go ahead and put a mark down here. That's where my x value, or the 18, would be. And I can see that's further than 1 standard deviation away. And that's good to know because the z-score really represents your standard deviation in this. So a z-score of what do we have? -1.29. I can see that's further away than a standard deviation of just -1. So that z is really representing how far away from that mean are you going to be. And that's kind of what I'm looking for when I say give me a visual interpretation of what's going on. We've got our mean labeled, we've got the standard deviation labeled. I can see where my data point is, the x point is in relation to that standard deviation, and then my z-score, negatives are going to point to the left, any positive z-score would be pointing to the right, being above it, and since we're at -1.29, I'm further than one standard deviation below. So that's kind of what I'm looking for a visual interpretation, and again, getting the actual z-score wasn't really too bad as long as you have your formula to look at.